Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All about electricity. Part 8. Lithium iron phosphate batteries Part 2. We will continue discussing using single lithium iron phosphate cells for your battery bank and things you need to know and understand, like what a fully charged and discharged cell voltage is and what causes damage to cells. How difficult is it to determine the state of charge of your LFP battery bank? What can happen when your cells are unbalanced? And why do you need to have the capacity of all cells be the same? From now on, unless otherwise noted, the battery bank we will be talking about will be a 24-volt system. As this is what I have, you will see real examples on the expanded presentation. If you are planning to have a 12-volt system, just divide what I present here by 2, except for the cell voltage. Remember, the single cell voltage is the same for 12-volt, 24-volt, and 48-volt LFP batteries. Now, to continue with the single cell basics, what we will next talk about will seem to require a lot of work on your part. Yes, math is involved. I understand that for some, all you want is to get a battery and use it, and I understand that, and you can do that. But you will pay for it, and you will not have an in-depth knowledge of the underlying parts of your battery system, such as battery balancing, battery management systems, or BMS, and other protection circuits. So, when things go wrong, you won't be able to troubleshoot the problem. Building your battery bank using single cells gives you more control. I'm all for building a less expensive battery bank that gives me all the electricity I need. Now, deeper into the weeds. What is the voltage of a fully charged and discharged cell, and what causes damage to cells? An LFP cell has a fully discharged to fully charged voltage of 2.5 volts to 3.65 volts, with a nominal voltage of 3.2 volts. Yes, 2.5 volts is considered a fully discharged cell. You do not want to go below this, or it will permanently damage that cell. Also, do not charge a cell higher than 3.65 volts, or you will damage the cell. 8 fully charged cells would make a 24-volt system have a maximum voltage of 29.2 volts. Now, the biggest killer of any battery is heat. Overcharging, over-discharging, draining a LFP cell down to near 2.5 volts, or charging a cell up to near its maximum of 3.65 volts, charging and discharging at very high amperages, all generate heat. You should avoid this. But let's continue with the basics. Now, to the state of charge of an LFP battery, denoted as SOC. How difficult is it to determine the state of charge of your LFP battery bank? Most inexpensive meters will use the total voltage of the battery bank to show its percentage of state of charge. This is fine for an acid battery, as when its voltage goes down, so does your state of charge. However, with the discharge characteristics of an LFP battery, these inexpensive meters won't give you an accurate state of charge. Remember, during discharge, the voltage of the LFP battery remains fairly constant between 90% state of charge and 10% state of charge. That's a per-cell voltage between 3.3 volts down to 3 volts per cell. You could be drawing power for hours and hours and have the single-cell voltage remain between 3.1 to 3.2 volts. It's very hard for those meters to accurately detect this. There is equipment you can use to more accurately show the state of charge for an LFP battery bank, which will be covered later. What can happen when your cells are unbalanced? To complicate things even more, all the cells in your battery bank need to be very close to the same voltage, or other problems are created. This is called balancing the cells in your battery. Ideally, all the cells in your battery should have no more than a 100 millivolt spread between the highest and the lowest cells. 100 millivolts is 1/10 of a volt. Here are the reasons why. If 7 of your 8 cells in your LFP 24-volt battery are at 3 volts and the 8th cell is at 3.4 volts, your battery will either overcharge the one 3.4-volt cell, damaging it, or when that cell reaches 3.65 volts and your protection circuit turns charging off to not overcharge the battery, the other 7 cells will not be fully charged. Or, if 7 of the 8 cells are at 3.2 volts and the 8th is at 2.9 volts, that 8th cell will either over-discharge or discharging will stop due to the protection circuit stopping discharging. In either case, you will not get the full capacity you expect, or you will damage the unbalanced cell. Again, there is equipment you can use to reduce this, and we will talk about battery bank balancing in the future. The reason you need to know the voltage of each cell in your battery bank is that if a cell is much lower or higher than the rest and cannot be balanced with the others, it will need to be replaced. If you purchased one of the pre-built 12-volt or 24-volt LFP batteries, you will not be able to do this, so the complete battery will need to be replaced. If you built your own battery from single cells, you would be able to replace that one cell for much less. This is also the reason to have extra cells available to replace defective ones. And why do you need to have the capacity of all cells be the same? All cells in your DIY battery bank must be the same capacity and should have the same amp-hour rating. Do not mix lower amp-hour cells with higher amp-hour cells. As an example, if your 24-volt battery has 7 cells rated at 280 amp-hours, and the 8th cell is rated at 95 amp-hours, the total safe capacity of that battery will be only 95 amp-hours. Doing so will reduce the total capacity of your battery bank to the lowest amp-hour cell. That's enough confusion for tonight. Please don't get discouraged by this confusion, and remember to watch the expanded presentation on our YouTube channel, which will have charts for better understanding. Next week, we'll continue our All About Electricity series and discuss how do I build a 12-volt battery from single cells? How can I see the battery's total voltage and each cell's voltage? And how do I balance the cells in my LFP battery? If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.